In question 1, we learned about how we could calculate the volumes of reacting gases if all the reactants and products were in the gaseous state, but not all reactions are in the gaseous state, and that's where we need to use moles more and more. So let's look at a situation. We've got the definition of a mole. We've got 1 mole of a substance is 6.022 by 10 to the 23 particles of that substance, and that means if you've got 1 mole of a chemical, you've got 1 lot of 6.022 by 10 to the 23 particles. If you've got 2 moles, you've got 2 lots of 6.022 by 10 to the 23 particles, which is 12.044 by 10 to the 23. If you've got 5 moles of a substance, that means you've got 5 lots of 6.022 by 10 to the 23, which is that number there, and so on and so on. Eventually you get to the point where you hopefully realise that if you've got n moles of a substance, you've got n lots of 6.022 by 10 to the 23 particles. And this is where our math starts coming in. And that means the number of particles you've got is the number of moles you've got, n, times Avogadro's number. So if you needed to know how many particles in a substance you have, if you know the number of moles, all you have to do is times that by Avogadro's number, and you can tell exactly how many particles in a sample you have. So you can rearrange that if you like. Hopefully by year 11 you see this equation here, you can rearrange this to make anything the subject, whether it's Avogadro's number or mole, the number of particles the subject. Often you'll be trying to find number of moles, so you want to make number of moles equals. All I've done is divide both sides by Avogadro's number. So number of moles is equal to the number of particles divided by Avogadro's number, and you should be able to apply both those equations as required. So that leads to example 2 in our notes. And example 2 is how many molecules of chlorine are there in 8 moles of chlorine gas. So what a good thing to do is when you're starting a question, write down what you know and what you don't know in the question. So first of all, what is a molecule of chlorine? Well, I know a molecule of chlorine, or a particle of chlorine, is Cl2. Chlorine exists as diatomic molecules. And what else do I know? Well, I know the questions ask me how many molecules are there, or how many particles are there in this 8 moles. I've been told I've got 8 moles, and I know, just as a fact, I know Avogadro's number is 6.022 by 10 to the 23. I also have an equation, which is number of particles equals number of moles times Avogadro's number. The reason I chose this equation is because I'm trying to find the number of particles. So straight away, here's an equation that tells me the number of particles. So I can say number of particles equals number of moles times Avogadro's number. All I've got to do now is substitute. I've got to put 8 in there for the moles, and I've got to put in 6.022 by 10 to the 23 for Avogadro's number. And so if you're listening on, I recommend you type that in your calculator and pause the video for a second to see if you can get the right number, because you need to know how to put these in your calculator properly, and if you can't, that's when you need to get some support. So let's have a look at what that number should have been. When you put that in your calculator, you should get 4.818 by 10 to the 24 molecules. That's how many molecules there are inside 8 moles of chlorine gas. Now, the only number that we have here is that you require significant figures for is this one here, Avogadro's number. When you're told you've got 8 moles of something or 5 particles, that's considered an exact number. Significant figures don't count. So as accurate as we can be is the accuracy of Avogadro's number, which is 4 significant figures here. So our answer here should be 4 significant figures as well. Looking at example B, how many atoms are there in 8 moles of chlorine gas? Well, we just figured out how many molecules there are in 8 moles of chlorine gas, and this requires us to be doing a little bit of chemistry thinking. So from part A, we just calculated there's 4.818 by 10 to the 24 chlorine gas molecules in 8 moles of chlorine gas. But that's not what the question's asking us. It doesn't say how many molecules there are in 8 moles, it's asking us how many atoms there are in 8 moles of chlorine gas. We've got to think to ourselves, well, each chlorine molecule has 2 atoms of chlorine. And therefore the number of atoms of chlorine will be double the number of molecules, because for every molecule we've got 2 atoms. So the number of atoms of chlorine will be 2 times the number of molecules of chlorine. And we can simplify that for pretty much all equations in a minute. So let's just get this question out of the way. The number of atoms will be just 2 times that number of molecules of chlorine, which gives us 9.635 by 10 to the 24 atoms of chlorine. And we can simplify this. This is true in all situations. The number of atoms we have is the number of molecules we've got times by the atoms per molecule. Some molecules have lots of atoms. For example, sugar, we know is C6H12O6, and that's got, 24 atoms in it. So if we're trying to figure this for sugar, we'd have 24 atoms per molecule in there, for example. But that's an equation we're not going to use very often, but you can use that to answer some questions as required. The next question you've been asked is, if you've got this many molecules, 2 by 10 to the 16 molecules of chlorine gas, how many moles of chlorine do you have? So this time, we're not being asked for the number of particles, we're being asked for the number of moles, which leads me to come across here. This could be a good equation to use, because this equation will tell me the number of moles. So what do I know from the question? The question's told me that I've got 2 by 10 to the 16 particles. I've been asked to find the number of moles, and I know Avogadro's number is 6.022 by 10 to the 23. I then choose my equation. Number of particles equals number of moles times Avogadro's number. Well, that's okay, that'll work, but I've got to rearrange that. So why don't I jump straight to this equation? Number of moles equals number of particles divided by Avogadro's number. The next step is always substitute your values in. So I'm just substituting in for number of particles, which is 2 by 10 to the 16, and substituting in for Avogadro's number, which is 6.022 by 10 to the 23. Put that in my calculator and get an answer. So here, once again, is a chance to practice your calculator skills. Pause the video while you type it in, and then check the answer. Okay, and the answer should be 3.3 by 10 to the negative 8 moles. And this time I've gone to two significant figures because I definitely have a number here which is two significant figures in my question. And that's it. That's how you can use our first mole equation. Number of particles equals number of moles times Avogadro's number.